Hello. Today we are going to look at the atom and why that's important in the topic of electricity. All right. So before we do that, I want to show you how small an atom is and what makes up an atom. All right. So this is you, a human. Okay. Unless you're like me, who's an alien. All right. This is how big you are. And this is a dodo. This is a beach ball. This is a rafflesia. The dodo's dead, unfortunately. All right. Now, what is bigger than you? Well, if I take this slider bar and I keep going and going, you can see everything that is bigger than you, all right? So a lot of landmarks, states of countries, moons, planets, and if I keep going, the edge of the universe, all right? So you are very small. You're a tiny speck in the universe, but that doesn't make you not important, all right? You're very important. Now, I'm going to go the other way. What is smaller than you? So let's go. Let's go back to the human being. And let's go even further down the line. Oh look, a human egg. That's where half of you come from. All right, white blood cell. What's smaller than that? Let's keep going. It's going to keep going. Oh look, a virus. Here, past this point, we have DNA. That is what makes up who you are. Now, even smaller than a DNA, let's keep going. It's going to keep going. We finally come to the atom. So if you remember from maybe year 7, you might have learnt about particles and matter, right? So this is what we're talking about. These particles called atoms makes up matter, all right? Now, I'm going to keep going further and show you a hydrogen atom and a helium atom. Now, we have a couple of things we need to know. This little egg-shaped thing with the yellow thing spinning around, all right? Can you see that? So this yellow thing is called the electron. It's circling the outside of the atom. So if it's the egg, if it's a fried egg example, the electron would be on the outside of the egg white. Now, inside an egg yolk, let's just say, all right, we have a couple things. We have a proton and a neutron, all right? Now, let's just say covering these little protons and neutrons is what we call a nucleus. So the nucleus contains the protons and neutrons. Now, electricity is because of the movement of these electrons. All right, so the ability for the electrons to move is what allows electricity to flow, okay? And they have a negative charge. Now, that is what electricity is. It's the movement of these electrons when they come off and start moving around from these atoms, okay? Now that we know that, we need to learn a few other words, okay? So we need to know what current, voltage, and resistance is in an electrical circuit. Now, we've drawn electrical circuits before, but we're going to throw in these 3 new words here, and I'm going to explain what they are. To do this, I'm going to draw you a couple of things and bless you with my art skills. So I'm going to draw a person, all right? This is me, who's very angry, and I have a water pump, okay? I have a water pump. Now, attached to the water pump, let's just say, is a hose that goes around and loops back here. So water flows through the pipes or the hose around and comes back to the pump, and it keeps going around and around. All right, so bear with me here. So we got that now. So we need to learn what a current, voltage, and resistance is in a circuit. So imagine this is an analogy. This is a water pump and some hose system. Imagine this is your electrical circuit now. All right. Now the water pump, the way it works is it puts pressure in there and it forces water through your hose. Okay. So effectively, this is our power. So your battery or your power pack. All right. So your power pack is basically forcing the electrons to move through your circuit like a water pump. Okay. So voltage, all right, is related to your power pack or your water pump. So when I say voltage, it's how much pressure you're putting into your thing to push the electrons or the water, okay, through your system. Okay, now what is current? Well, let's just say this. I'm going to put more pressure in here, so amp up the voltage, and I'm going to push water or the electrons through my system. All right, now the flow of water is the flow of electrons in this analogy. Okay, so when I say current, let's just swap the colors here so it's a little bit easier to see. Excuse my bad handwriting. My current is how much electrons are flowing through my circuit, or in this analogy, it's how much water is flowing through my circuit or hose. So if I put more power in or put more pressure in, I'm going to make more electrons or water to flow through my system. Okay, now what's resistance? All right, last word, resistance. So I'm going to draw another person here. All right, this person is extra angry. All right, he does not like science and he hates experiments. Okay, so he comes along and he steps on my hose. Okay, now if you step on a hose with water running through it, does water flow through the hose? Probably not as well. Okay, so this guy here stepping on my hose is putting resistance to the water. It's stopping the water from flowing through my pipes. So if I said resistance in an electrical circuit, it's basically saying, what are you doing to the circuit to stop the flow of electrons?